heavy. What I want to do is get down this little bar. Because this is basically what you can demonstrate, like if you want to go around, that you can take the normal, ordinary motors, right? We'll show you this. You were asking questions about this light. You can take normal, ordinary tape drive motors. And you were asking about the radiant energy. So you can demonstrate the radiant energy.
Can you start it up again, John, from scratch? We'll see if we can get that.
That's the radiant energy, and then when you suck off the radiant energy, right, to the next battery, right, watch.
Goes off.
And accelerate. That's a fast one.
Yeah, try.
Well, it's putting. So here. We'll just put this meter on the output battery. Now let's turn it off. So you can sit there and not consume anything. And you can see this battery doesn't want to sit up there at that level.
Going down. 13,
Oh yeah,
4,
it's going to go to standing. That's what all lead acid batteries do, is they go to standing, and this one you could sort of take with you. I mean, you could always demonstrate it.
Which is 12. Standing's 12.
Yeah, this is 12 volt, and actually what I'll do is I'll hook it all up when you're ready to do what you're going to do. We'll put the right cables on it and everything, so, and you'll buy your 2 batteries or whatever you're going to do.
Right.
But here, now, so we'll start this again, and we don't want to hurt this meter, so we're going to take this off here. And you can see the radiant energy there. And we'll show you that the battery's still right there.
13 volts.
Yeah, now watch, we're going to give the radiant energy to the battery.
And that started to go up when you hooked up.
Well, when I take the output from this,
You put it on the battery.
yeah, well that's what you want to do. You want to charge the second battery. You want to be able to use this power.
So basically, this battery runs this motor,
Triggers it.
triggers it,
Right.
and the circuitry will pulse, trigger the radiant energy.
And it goes here.
That goes in there.
Well, yeah, see, look, it's,
So the net result.
so let's turn it off and watch it go down. And you can see there's no battery feed here at all. There's no generation.
Oh wow. That's just the standing voltage of that battery now, which is not decaying.
Is this decaying? No, this is keeping going, right?
No, that's
No,
okay.
it's starting.
That's decaying.
Yeah.
But there's no generation action.
Right.
It's not a generator.
Oh, I see.
So you're
as
at
soon as
stop.
you stop this, yeah. I see what you're saying.
This is a triggering mechanism.
Right.
Right.
Made out of a tape drive motor from a Sony camera. That's what that's made out of. Okay, so you can see that there's no generator action because it's coasting to a stop.
Right. Right.
That's kind of weird, isn't it, Tony? Because if I take and I short
Yeah.
this out, it's gonna whoop,
Yeah.
stop.
Yeah. Yeah.
So it's totally got all those fields canceled out.
Is that a modified motor or a stock motor?
No, it's stock.
You haven't built it, you just took the motor and.
Just took the motor and put took off the shield and everything and said, okay, we'll put our circuit here and it'll do it.
Oh, interesting.
So you can just take an off-the-shelf motor and do that.
That is fascinating.
That's what that shows. So now you can see nothing's going to change here when I hook it up. So nothing's leaking from that battery to this battery. See? It's not doing that at all.
So it is the motor that makes the difference.
Well, it's the triggering
It's the triggering
mechanism.
mechanism.
Now watch. Let's look at the rating again. That's indicated by these two neon lights. That it's high voltage. See? I'm gonna put your finger there. Grab onto these two. Okay, so now watch. And we'll put this on there. You can see that battery's there, right? Watch. Climbing up.
But this is not one where when you take the load off, it blows up the
No.
machine.
No, because it's got the protection, you know, and it's low enough voltage.
So,
Right, you get that to 24 volts and the wheel will come flying off then.
so the protection is your little lamps?
Yeah.
Your lamps, okay. If you didn't have that, you'd have a set of two bulbs.
Right.
Is it?
That is a standard off the shelf. It's what they throw out in the garbage. You know, now we got a battery, probably not a very good battery over here. Something that's even bigger than this battery, right? And you can see, we'll just hook it to this battery. See this battery,
And all this trigger circuit will put out is radiant energy.
Yeah.
It won't put out anything else.
no, it's not putting out anything else but the
Just
radiant.
radiant energy.
You see it's bringing this battery down because it's charging it.
Right.
That's what we got anything in it.
So the trick, quote unquote, is what your circuit does with the output of the coil?
Yeah. Let's see if there's anything in there. Nothing in this battery. See, but it's trying to adjust to this load. Hear it?
Yeah.
So if we take this, see, there is. So you can see that this is a dead battery, and it's going to put the charge in there. Here. Now watch. Pretty dead, Tony. Probably been sitting around for a couple of years. But it's going to put it in there.
Take a logo.
Of course, this one's a good one. Pretty sure this is a good one. Yep. But it's just the idea, see? To get a good battery on there. And then you can just watch it go up.
When you had that bigger light bulb plugged in and you took it away and it lightened up and you put it down close, the light came on again. Is that
Yeah, this post here, see?
okay?
It's just hanging there. There's something in it, but these have been laying around dead. I think these were left over from the shop way down there. But to even get that much in it,
Yeah, okay.
you know,
No, I thought the other end was off, that's why. Because you've done something like that last time you were here.
yeah, I mean, you're talking about a totally dead battery there.
Right.
That was a neon bulb last
Yeah.
time. This is a indicator this.
Yeah, if you even light that light to have anything in this battery.
Yeah.
You know, and this will want to put it there. See?
See some bubbling.
Yeah. Yeah, cold boil. So take it back over here. This one's got 15 volts in it. And just see the radiant? Bring it up. It's gonna take it a while because it's gotta be unaccelerated.
Okay, we're looking at a brushless motor, and one of my visits to this shop here, John had made this brushless motor here. So I replicated this exactly. I don't have mine here. But we have a dual SSG circuit here.
SSG is what?
Simplified School Girl motor. And so what John did is he took a conventional motor, brushless motor, out of the tape motor, and took out the circuitry, which is on top here, and just used the coils and the magnet as a motor, and was able to charge batteries while he was powering the motor.
So this motor is out of a what?
Tape motor?
What do you mean by a tape motor?
It's out of a tape editing machine
Okay.
from NBC. It's a capstan motor.
Okay.
So this is a little bit more powerful one than these fans. So I took this home and I played around with it, or I made my own at home. Played around with it for about 6 months or so, and then I got the idea. Well, I'll just try one of these, conventional fans, because it's the same kind of motor. So I started off with a really small one that you'd find on a computer, maybe 2.5 inches, and that was, an interesting. I got some interesting results from that. So this was a little bit bigger one, about 4.5 inches. It's just a Radio Shack, almost 4-watt fan here. I just built this one the other day. So again, you take it apart. You take out the circuit, which is in the back here, and then I just removed that, and I used the wires that were inside there, just like this one. What I was, interested in doing is seeing the same thing happen with this model that John had made in this fan. So I did that, and I thought it was a pretty good motor to use to compare, to find the mechanical efficiency, because the RPM is rated in the CFMs. So if I can get the RPM on this brushless motor to what it was originally, then I can see how much work is really being done. So we'll just look at this one for a moment here. Now I've got this, it's overrated for these batteries, but you'll be able to see it. This battery is charging, this battery is powering it.
Which battery's powering it?
This battery, well, this one is powering it, this one's charging.
So they correspond to the two batteries in the same order?
Yeah, they correspond.
Okay.
So you've got about 100, about 90 CFMs coming out of this fan here. What was interesting with this particular setup is we were running this all day on a different set of batteries all the last couple of days, and the primary battery just sat there. It was quite unusual for this setup, but you never know what to expect on some of these systems. If you want to look here, this particular setup,
It just went up, Rick.
yeah, this one's kind of fluctuating. It's probably at about 100 CFMs there. So this was the same circuit that John was just using. We're
Using in the window motor?
Window motor. Now what I've added here is just a very, very basic capacitor pulsar, which I'm just using a capacitor and an SCR and a little diode. And that's converting the negative energy output of the circuit into more of a positive energy. And this gives me the capability of rotating these batteries around. As we just went over, if you're going to mix the energies, it gets difficult. It's difficult to run the SSG off of negatively charged batteries, and that's a whole thing to explain. But so this is just a cat pulsar, a basic cat pulsar. In fact,
Cat pulsar?
capacitor pulsar is what we call it.
Okay.
Cat pulsar. And when I actually added this to this particular fan, the amp draw went
The what?
The ampere draw from the primary battery went from 550 milliamps at 12 volts to 475 milliamps, just by adding that little capacitor and SCR. Now, what I have here is a larger setup. I don't know, is that too close here? Which I made a little case for. This one's in the process of being constructed. The idea, this is a 6-inch fan, another brushless motor. Exactly the same kind of motor inside. There's 4 little coils, and you can see on this one the coils on the other side. This is just a larger one. This is a little kit that I put together for people to test out. So
And what are they testing out?
well, they're just being able to see that, with a fan, now they can charge a battery instead of just wasting that energy. And the idea with these setups is you can rotate the batteries back and forth and keep the fan going so long as you rotate the batteries back and forth.
And so long as you're using a positive energy.
Positive energy
If
with
you
the
use
capacitor.
positive energy.
Yeah. So I've got on this one, some switches, double pole, double throw switches to rotate the batteries. You've got 4 wires here to change them, one from being the primary charging or powering battery to the other one being the charging battery, and then flip them back and forth. And depending on the battery size that you're using, these are very small batteries, so they're not going to last. The primary battery is going to drain pretty fast, so you'd have to rotate it back, every so many hours. But I've got the same circuit, a little bit bigger, on a ceiling fan that I ran for several months last summer, where I just, rotated it back and forth between the 2 batteries. So the energy from one battery will go down, and then the other one will be charging up. And then, when it goes down low enough, you just flip the switch, and it'll just keep on going. Now, one of the things that, I don't know if John's mentioned today, but you want to give the battery some rest. So in this system, it would be better to actually stop the system for a little bit, give it some rest, and then flip it and rotate it, and then, or maybe have another battery bank. So here's another thing that's very interesting. I'm going to put a little bit of, load on this. And of course, if you look at the voltmeters, you find that the primary battery that's powering the system will draw less.
The primary battery being that one, okay. Right, you load it up and it takes less power.
Now, on a conventional motor, it would be the opposite, where it would take more energy, it being under a more greater load. So you can see it going down, but yet, and look at the charging battery, which is right here, and it will actually charge a little bit better. Now, there is a sort of a mechanical sweet spot that I've found with this particular brushless motor conversion, and that is almost to the point of stopping it. And that's just, that's just an interesting thing to look at and experiment.
So you've released the load now.
And see that the rate of charge is slowed down a little bit, and it takes a little bit more to power.
It just went into resonance now.
Yeah, you can hear it. If I had an amp meter, which I do in the other room, to watch that, it would shift. You would see the amps go, just, it goes through about 2 or 3 shifts.
Right. We saw that on the previous filming with John. You could see that.
Yeah, with that larger motor over there.
Yeah.
So we have, you can do this with any brushless motor. And so what I like to do on this one is I put a little reflective tape here, and I use a tachometer to measure the RPM. And what I've done is have one that's unmodified and just run it, at the 12 volts, or this one's a 24 volt system, and monitor the RPMs for the given amount of energy that it takes to run the fan, and then compare that to this fan that has been converted, and try and match at least the RPM for the power ratio, but then at the same time charge another battery or several batteries, which I've been able to do. Now, one thing to note about this, just like in the regular monopole motor, is that the wire inside gives you different kinds of results. This one is the exact identical fan that I got at Radio Shack. And this one is a thinner gauge wire, and it is actually more efficient than this one. But this one only gives me a certain amount of power. So that, if you want to have a really efficient system, you can go with a smaller gauge wire to a certain extent. But if you want to have more airflow here with this size of a fan, then you're going to have to go with some higher gauge wire. So we were just doing some experiments trying to match it in the way that I was talking about it, trying to get the RPM exactly the same as the unmodified motor for the same amount of wattage, which is 3.84 in this particular fan. So it just takes a little bit of time to figure out which gauge wire will work to do that kind of thing. And there is if you want more power on these fans, you can sacrifice some of the charging. That's what I've found. So I tend to be a guy, I used to be a mechanic, I like torque, I like power. So I tend to push them pretty hard. But it's not always the best kind of charging, unless I load it down like this. And then you can see it starting to go up. So we have several of these as kits. I've got a 10-inch fan that's a little larger than this 6-inch fan, and it all does the same thing.
And so you sell these for experimenters to...
Yeah, what happened was we have a little kit that is just the basic monopole, as we just saw in the film, where there's a coil and a basic circuit and instructions on how to put it together. But people were complaining, well, I don't want to make a big wheel and I don't have the... So we thought about putting together a little kit that had all the parts in it, and it was, professionally machined, and it gave a direct comparison to the motor, so you knew exactly the difference. Because people were saying, well, there's no real mechanical power in this. Oh, I mean, it's not really meant as a motor. It's more as a mechanical oscillator, as in the patent. But there still was that, as John said, 23% mechanical power there, which needs to be appreciated. So I've made about 140 different monopole SSG schoolgirl setups over the last 3 years, and just experimented with different kinds of arrangements. And so this is just one of the latest ones that we've done.
And then run this one.
Yeah, I was going to do that.
The battery guy understood.
Yeah,
One battery guy understood
Kevin, yeah.
that you just can't charge batteries that way. So whatever's here is totally different.
Right.
And the thing that we're actually trying to get across here, we're trying to make this as simple as possible for people. It has to be as simple as possible for people because they really don't understand what the energy is. And they're not willing to take the time to go and research for years and years and years to figure out, well, hey, what these guys are terming free energy is the mechanical energy. Is the mechanical energy they're getting for free. They've never had anything that they could run as a toy, and you can consider this a toy. They've never had anything that you could take and get this mechanical energy out of it, or wind, to cool yourself off. And it would be very easy to drip water by this, and you have an air conditioning unit that recharges its own batteries.
Yeah.
But they're not willing to take the time to understand that. The future is about efficiency. It's about understanding what these forms of energy are. As we demonstrated earlier, that negative energy is one thing and charges a battery totally different than what positive energy charges the battery. So, we have to understand the forms of energy, and what everybody's terming as free energy is just a change in the energy. Tesla wasn't going to do anything mystical here.
And I would imagine the government isn't going to want general information known either. They'd want to, proprietize it in some way, if that's a word.
The government has not indoctrinated the people into being efficient about anything. It's all politics. It's all, what can we hide, what can we take away, how much can we control these people, what kind of a slave do you have to be to run this government?
Yeah.
It's very simple. You go to work, you give them 60% of your paycheck, even more. Because when you go to the store for food, you're paying taxes on the food, you're paying taxes here, you're paying taxes there. Pretty soon, you know what you're left? You're left with about 2% of your income. You start raising the fuel costs, and you create a debtor nation. You create a society of slaves. They don't have anything. They're not going to do very good work. They haven't figured that out yet. Okay, you're going to get half-assed work, and that's just plain and simple. That's what you're going to get. You're not going to get anybody that's worth a crap. And the reason that there is not an efficient motor out there that draws its energy from the ambient surrounding is because you have people that are feckless.
Right.
Okay, we've sort of broken through, and we've touched the first and second base of this operation. Tony spent a good deal of time filming people that supposedly, mysteriously make this witchcraft work. See, to a normal engineer, this is witchcraft. This is something he wouldn't do. It's not in his textbook.
But
When he really needs to be engineering from the vacuum.
Right, but you're not doing this for the chat group, are you? You're doing this to try and get a bigger business or whatever that's going to...
I'm doing this for general mankind, to
Okay.
get out the
Yeah.
knowledge to general mankind. Now,
But you're hoping, I would imagine, that somebody responsible is going to take this and change the way we do
And do
electricity
something
and do
with it,
more
because-
efficiently and, yeah,
exactly.
yeah.
We're not
You're
here
interested in
to
Joe
insult
Blow and his-
any engineers
Right.
or say your theory doesn't work, because their theory does work.
Mhm.
You know, I've engineered my entire life with their theory from the textbook, and I can tell you it can make the power meter spin. I wanted to look at the other end.
Yeah.
I wanted to look at the end that Tom Bearden was talking about. What is Tom writing here? Is Tom wasting his time writing? That was my question. No, he's not. This stuff actually does work exactly the way Tom Bearden says it works. I'm not here to insult engineers, once again. I'm just here to try to say, hey, gee guys, let's have a look at this. What's this doing that we're missing? Can't we engineer this into our circuit some way to make my transistor radio last like 40 hours more or 100 hours more? Or gee, when that battery's dead, can I just take the one out of here and put it over here? No, you've got nobody that's willing to stop their normal routine and really look what's going on around them.
Yeah.
They want to go down to the local stand and get some cheese for free. The internet is about freedom of speech. Sharing ideas back and forth. But you can see that it's been totally infiltrated by naysayers and skeptics and people that want to bring about the whole total socialization of this without any of the benefits of it. You got to be able to grow your own food in the future, pump your own water, you know, and make sure that when you're pumping that water, that another battery is being recharged at the same time you're taking your bath. You know, we're trying to do this currentless. We're not trying to use very much current doing this at all. In fact, the absence of the current, the more the vacuum adds energy. The more current you put into the circuit, the less the vacuum energy comes in. This is about the change in society. Can mankind become efficient? That's what we need to know. So this is sort of a little test. Here's the information. What can you do with the information? Some people are gaining knowledge and learning. Others, it's just a hobby. It's frightening. It's very frightening to know that we don't have these energy sources and that we're running out of fuel and oil, supposedly. I don't think so, but,
Yeah.
you know, and that we're warming up the earth, that's poppycock. These cycles on the earth have been going on for thousands of years. All controlled by the sun out there. It's all about magnetic fields and what the magnetic fields do. On one side you see the ice caps melting, on the other side you see the ice caps growing. Who's on first here? That's what I want to know, is who's on first? Does it work or doesn't it work? Can we do something with it, or do we have to throw it aside and start over? That's my question. I've done the best I could do. I've given them the most information I could give, you know, from all my years of research. And now it's just, I leave it up to them. You either take the leap or just face the future. That's all you're getting from me, Tony.
That's very
Right.
sweet.
Very good, John.
You're probably going to put it in there too, aren't you?
Some of it, at least.
I'm going to cut it and mangle it so badly that
He's going to make you say something else.
yeah.
He's going to be a globalist and a global warmer.
No, I mean, you got it right
When
there in a nutshell.
Yeah.
You have the whole thing in a nutshell here. You have this right at your fingertips. If you don't choose, and don't complain about the price. I spent 40, almost 50 years spending my money to figure it out. You're getting a deal if I say $75 for the book.
Yeah.
Think about the guy that's filming. He hasn't asked for a dime. What's going on here? Today you have access to all this information and you have the internet. But they're abusing the internet so bad that they're just going to take it away. Then you're not going to have any information. You better hope that you copied all the stuff off on a piece of paper and that you have so you can do it. I think we've done our best.
Yeah.
Yeah, I think so too.
And there's more. We're growing, and we're sharing a little bit more each time. We're not hiding anything. There's nothing in here. You don't see any black boxes on top of anything. You can see the circuits right in front of you. You can see the wires.
All clear.
Okay, Rick's got it in a clear plastic box. Okay, there's nothing hidden here. We don't have to hide anything because we're not frauds about anything that we're doing.
And the thing about these kits is you build them yourself,
Mm-hmm.
or you could make it yourself. You can go to the store and buy it, buy the parts wherever you want to buy them, and it'll work.
On the internet groups that you participate in and that you run, Rick, about how many people are in these groups?
Well, we started off with a Bedini Monopole 3 group, or Bedini Monopole group, and we had hundreds of people first year, and then that eventually we made into an advanced group, and now we have a similar group called Bedini Monopole 3, and there is maybe 700, 800 people on that now. It just grows every day. More people join that group, and most of them don't participate, but a lot of them do, and they replicate their version of these. When I say their version, they get their parts. They get their parts from wherever. They build their motor whatever size, and then they post the results. So we have people all over the world. And then, of course, the group is open to the public, so everyone can view it without even joining the group. So I estimate there's thousands of people watching that. And what we're trying to do there is give the basic circuit without all the advanced stuff, so that everybody can focus in on that, understand it, which it sort of makes it easier on me. I don't have to answer all these questions all over the place about every different circuit. We've got to start off the basics. And once you understand, what we want to do there is show two different things. That you can restore ruined batteries or desulfate batteries. And then we also want to show how there's two energies, as John's been talking about. Once you get to that point of really understanding there are really two energies and how they work, then you'll naturally know how to move on. But most people just have this gold rush fever, right? John said,
Yeah.
where they're
Gold fever.
Gold fever. They're just impassioned. They want free energy now, and they can't listen to any instructions. So they'll come in, they'll see the basic circuit, and they'll say, which is just this right here, and they'll say, well, I can improve upon that. it's a transistor and a diode and a resistor, and we had another diode off here to go to the charging battery.
So that's the basic circuit.
So that's the basic circuit with an inductor, with the coil, and then the motor. Well, they want to do this and that and say, well, this is how you improve it. And they spend all their time trying to figure out
Well,
how to
one thing
improve
that's
it.
very important here, Rick, is it's already as simple as it could get.
Yeah. So why?
There's nothing difficult about this at all. You just follow directions and it'll charge your battery.
Yeah.
You don't have to be an Einstein to make this. Einstein doesn't work here. This is simplicity. The simplest form. This is the easiest way to show what the energy is. We couldn't make it any more simple. But most people are looking for sophistication. As I said, there's an old saying from Paraguay. I put all the gold, all the silver around the wheel for the eye of the ignorant. So he misses the whole concept of the simplicity.
Yes.
Who made that statement?
Paraguay is 1269 AD.
And he built
He built a permanent magnet motor while he was at war.
in 1269.
Yeah, and he said, he wrote it in a thesis. He said, I've dressed up everything so that your eye is focused on this blue capacitor or this gold spot over here, and you miss the whole workings of the motor. And he called it the eye of the ignorant.
And see, this is the
It was
thing.
quite profound because nobody ever duplicated it except for Lee Bowman.
So what I've observed over the last 3 years is John has laid it out again and again, the basic points, and people just miss it. They just go off here and there and make these demands and what have you.
Well, I'm not politically correct, Rick. My I's aren't dotted all the time, and the T's aren't crossed, and every once in a while something's misspelled or the punctuation mark's in the wrong spot. But you know what? If you don't understand street language, what are you doing here? You've heard the saying, book smart, life dumb.
But there's all sorts of people, engineers all over the world are replicating these. Not everybody posts their results. They send things privately on emails and that. But you have people who are, kids building these for science fairs as the original schoolgirl, 10 years old. Or you have people who are, the most advanced engineers. In fact, I brought this exact motor around with me in a box around the whole country this year, this winter, and I showed this on campuses all across the country, and I met people who were PhDs to your basic college student, and they were fascinated, as we discussed that. So a lot of these people have joined the groups and replicated these things. So there are a fair number of people who have moved on from the basics, but this is all that's necessary is to know what the energy is, as John's describing the boards there, and
It's sort of a primordial energy.
yeah,
It's like before electricity.
Precursor.
it's like
Precursor.
earth currents and all.
Yeah.
that.
And this kind of energy likes to see a high impedance. It absolutely does everything opposite
Yeah,
of what the conventional energy does.
yeah,
And as Tom Bearden points it out very precisely, that what we're looking at right there that's coming out of the wall is just a waste product.
yeah. That's what these are measuring waste.
When you talk about negative energy, is that on a par with positive energy, and they're both subsets of precursor energy, or is negative energy essentially precursor
It's
energy?
precursor.
So negative energy is
Yeah,
essentially
it
precursor.
has to come through the vacuum before it can become positive at all. You know, this is all conversion.
So radiant is the same as precursor, is the same
Yes,
as negative.
it's an energy that's been here since the dinosaurs.
Okay.
And we're just figuring out that energy flows without any current.
You can't really measure it, but it's there, and the battery's charging when it shouldn't be.
Mm-hmm.
Now you can put meters on it and they show something, but they don't correspond to the actual state of charge in the battery. And that's one of the major things that we're trying to look at on these lists, is what is charging your battery. It shouldn't be charging anyway, and it doesn't correspond. If you put a meter in line with it, no matter how you look at it, it's never going to show that it should be charging at that rate.
Yeah, but you might point out too, like that you get engineers who only know how to put a current meter in line.
Yeah.
And they're saying, well, there's no current here, so it couldn't possibly be
So
charging.
they don't even look at the results. They're not willing to charge up the battery and load it down. Charge it up, load it down, and see the actual work that comes out of that battery. And, they look at, like John says, they look at the meters and they say, well, it's not impressive. But what the impressive thing is to see what the actual energy comes out of this battery. Not to mention, it's making that battery better over time as well. So,
Very good.
well, I was just going to show here then a little bit more. If you want to come here and see, as I'm going to start this up again, and just to show you what kind of power. I mean, you can watch the voltmeter, but watch what happens. This capacitor is going to fill up and very fast and discharge very fast, but you can see the neon bulb.
Where am I supposed to be looking?
Well, you can look at either one of them. So the neon bulb is showing you. So that's how much power is going into that charging battery.
High potential.
High potential. So now what I'm going to do, yeah, you got to do it pretty fast, otherwise it's going to blow up this capacitor. So now what I'm going to do is show these batteries and swap these batteries around. Which on that one I have the switches that could just do that. But here we're just going to swap them around. So you can see, that the battery can be swapped around and recharged. And the other one powers it. That was just
the capacitor makes it possible, it converts the energy to a positive energy that the battery wants to see. So now it's more like as if you took that battery and you used a wall charger to charge it.
Yeah.
And that makes it possible now to switch the two batteries.
Yeah.
We're taking it out of the negative time domain and bringing it to the positive time domain.
Yeah. Now let's start it up again. Let's make sure someone over here.
So you've just switched batteries here.
Yeah. This is one that's let again. See, when you do that with the capacitor,
When
you
you
can.
spark it, you damage.
Well, what happens is it can, go back into the transistor and ruin the points. But so that's why we have the neon bulb on there,
Yeah.
so that there is some protection. Which many times I put a resistor in series with that, so it
Let's see,
doesn't blow.
take the charging battery out.
Oops, that's the wrong.
It's quite a,
So I wouldn't want to leave that off for very long.
yeah.
Otherwise, this is only a 200 volt capacitor, and that just go beyond the 200 volts. Right? There's no transformer in this. So how do you get a higher voltage than the battery that's powering the system. That's what people can't understand. This capacitor can actually be fully charged and actually explode. I've seen that. So you got to be careful with these systems. You got to know what you're doing. That's
So
why.
go ahead and run the tape motor.
Okay, so we're gonna disconnect this and.
So they can watch it there. And this will be...
Oh. Now what's going on here, John? The batteries. There's nothing powering it.
Yeah, there's nothing powering
Look,
it.
look at this.
Right. There's nothing powering it.
Now, this doesn't happen very often. This particular motor has been very strange. As I said, it was running all day yesterday and most of the day today.
It's basically running on its own capacitor discharge.
It's running on the capacitor discharge, but there's one wire here. One
Right.
wire is only connected to this
Right.
battery.
So you got a motor running just off one wire.
Oh no, wait a second, sorry.
Yeah.
Huh. Okay. Anyway, what I wanted to say was that these batteries, when I brought them in this morning, they were more discharged than they are now. You know what happened was, I think I switched my wires in the wrong position. Hold on a second.
That's possible with all these wires.
Yeah, this is why it's such a mess here. Sorry. Anyway. Where's this? Okay, that's what it was. This one is here. Okay, what we're going to do is run, let's just get rid of this one there. We're going to run this one right here off of these little batteries. I think John was calling this the chirper motor. Okay, there we go. Yeah, that's the problem. I had my wires,
Crossed.
yeah, mixed up. But it was still interesting what was happening anyway. I think that should be still fine for the video. Because, yeah, it wasn't running nearly as fast. It was like, what's going on here? That's why, that's why I added those switches in there. Because people always cross their wires. They get them backwards and just 2 flips of the switch, Okay, what we did is we removed that fan, and now we're going to go back to the original
Tape.
tape motor. You can see, again, if you let the batteries rest, they'll come back. And when I brought these batteries in this morning, they were discharged more than they are now. And I ran, I've been using these all day and swapping them back and forth. Okay, so this is the tape motor fan again. It is a brushless motor in which there's a circle magnet here on the top, and on these brushless motors there's north-south, either 4 or 8 poles around here, and then there's individual coils here. In fact, here's what it looks like inside. Ironless. No, well,
Ironless coils.
right here, yeah, this one. So now what we're going to do is look at, we got the scope hooked up. And this one you need to give it a good little push. You can see the charging rate, the discharging rate. And it's going to go through some phases here. It's going to go whoom. And this one draws a lot of power because this is pushing as it gets up to speed. So it's going to take a little bit to get all the way up to the maximum RPM. And we're not putting any load on it, so it's going to go faster.
Just to reiterate, Rick, which is the the driving signal battery, and which is the battery you're charging, and which are the corresponding meters?
This one is powering. I got them in reverse now from what it was before. This one's powering the system with the clips, and this one's charging.
Okay.
Now here's the difference. This one does not have the capacitor dump on it.
This one here is powered. And this one's in charge. Because if you take this off, see?
Oh no, I'm sorry. You're right. Yeah, you got it. I have it backwards. You're right. So yeah, you can see the neon bulbs come on here.
And the neon bulbs indicate what?
You're protecting the transistor.
Indicates the radiant energy in the system.
Now these ones also have resistors in series with the neon bulbs,
Keep them from popping.
because as you can see, this one can be run at 24 volts.
So
with this system.
because the radiant is essentially a gas, the neon is one of the only ways you've been able to find to indicate,
To detect it.
to detect it.
Yeah, which in the other DVD you can see
Right.
John showing that with one wire, and I've done the same experiments. So, taking it off, it's got nowhere to go, in a sense. And so you can see the scope shot. Now,
Let me get the scope shot here.
Well, one way to show this, Tony, the conversion. The battery's doing the converting here. But we can capture the radiant. Notice that this capacitor is very small, but look at the voltage.
yeah, that's the one we want to look at.
Okay, so now,
Those are 20 volts.
what's here?
It filled up that gap real good.
Yeah.
Let me do it again. Basically, when you use a capacitor dump system, you dump it across this battery that way. See, so this is charged, right? So depending which way it's charged, right? You dump it across the battery like that. And the battery bounces up real quick.
So we got 100 volt divisions here.
Yeah.
And look how high we're going here.
So we can see here that we could constantly keep
300
doing
volts.
this.
So that would pop those capacitors if you left it there, because it's over 300
right,
volts.
it's over 300 volts, and we don't want to do that. And we want to catch that. See?
Yeah.
And then we'll just send it to the battery because it's actually a better place for it to go. And then right away the battery starts charging.
And you can hear the motor change
Yes.
too.
Well, because
Yeah.
we're sucking all the energy out and delivering it to the battery.
Yeah. So the 1266 is the one you're charging.
Yep.
Yeah. So you put more load on the motor and the charging goes up.
Yep, in some situations, yeah. And
Well,
there's, yeah. Now this one, like I said, it's a different system because it doesn't have the capacitor dump on it. But yeah, it's going to take less energy.
What do we got on the
Now we can change the speed on this. Okay, now what I did was, let's change divisions so you can see that.
So what are you doing at the moment?
No, I'm just looking at the oscilloscope. So yeah, now this one we won't want to rotate around because we don't have the capacitor discharge. So it's a different kind of charge, and each person who experiments needs to learn the difference. So this is sort of and so if we want to change the speed on this, we would change those resistors.
Very good.
Wait, you need to limit the flow.
Need what? Need what?
When you're done with this, you have to go.
Oh, yep. I'm behind the camera.
Is that what he does in his movie?
Yeah, right? At the very end of the movie, he goes,
He always does that. Whenever I talk to him.
So I only watched the first 2 or 3 minutes and I knew it was rubbish. So.
"Well, all this gets edited out, though, right?
Yeah.
We wouldn't want to have that.
We want to sell DVDs, not to dissuade people from. Okay, is that it, Rick?
That's it.
Okay, great. Good job.